Thank you very much. And I'm just sharing the slides you should see now. And after Shree's wonderful introduction, including all the ethical aspects of this challenging but also offering loads of great opportunities field, I wanted to go a little bit into what is the current state and what can the future look like. And of course, within the realm of artificial general intelligence being around the corner and large models dominating AI at this very moment in many ways, the question is, how has this impacted on effective computing? And aren't we already at the moment where effective abilities are emerging in artificial intelligence anyhow? So we have seen in large language models all sorts of emergent behavior. They can summarize texts, they can recognize sentiment, and many other things they haven't been explicitly trained for, maybe from 10 million to 100 million parameters onwards, maybe from sufficient data at internet scale training onwards. So how is all of this impacting on effective computing? And even more so, what will be the future of effective computing in this framework? So without much further ado, the quote of this contribution is, "The world of effective computing has changed." And it has changed across modalities. We know the large models mostly from the textual domain. We also know it from the visual domain. So to start with, we could see, I see it in the vision modality, and I want to make an example from that first. But I also read it in the linguistic modality, and the question is, do we also hear it in the speech modality that Shree has just been talking about? Overall, much that once was is outdated, you could say, because we're entering a new era of effective computing. And this has just been released as an archive preprint, the paper I'm introducing here, but we will also talk about the contributions coming from the special issue and the proceedings of the IEEE special issue on effective computing. Matti Pietikainen and I have been editing and had wonderful contributions across the field, including, of course, the one from Shree. So what about the changes and how do we look at this? Well, the idea is to see if there is emergence in AI and large models already when it comes to emotion and affect, and how can we better visually showcase this than was starting with the visual domain by asking large models to draw, render faces of different ages, sexes, different skin types in different emotions. And we can also add different styles to make it a little bit more interesting, such as 3D or cartoon or photorealistic. So that's what we did. We looked at different emotions with my co-authors. We looked at different ages, young, middle-aged, old, man, woman, different skin tones, and yeah, I said different styles. And what you get from that, looking at the Ekman Big Six emotions, I would say it looks quite good. From left to right, we look at neutral, then fear, anger, and so onwards, the different Ekman Big Six emotions plus neutral. You can see from top to bottom the different styles, starting with photorealistic. And if you look, for example, in the middle here, you can see happiness, and it seems quite good to me. I hope you can share this impression. But the question is, can we also quantify if this looks good? So can AI also recognize emotions? And we can answer this question from two perspectives. We can first say, can AI already recognize emotion as shown by AI? So if AI tries to show emotion in different modalities like we're doing here. And then, of course, we can also ask, can AI emergently already recognize emotion in databases the effective computing field has been using before? So looking at the first question, we have been training Vision Transformer on the FER dataset. In other words, train a state-of-the-art model, a transformer with a big database that is state-of-the-art, and we can look at the different styles. And we can see that in 3D, anime, cartoon painting, and photorealistic, in this order, we have different quality of, recognition. So the 3D is almost giving us 60% accuracy across the Ekman Big Six plus neutral emotions. If AI that has not seen the training data and not seen the training data of the AI rendering the emotions is trying to get the emotions of the AI right. What we can also see is that the confusions are mostly with neutral. In other words, if the AI tries to do emotions, it seems to be too soft and not intense enough. Of course, you could be working on the prompt and say, make it really strong. But you could also, see that the confusions among each other usually are quite looking good. So in short, AI can do happiness very well already, both in rendering it, both and then as well as in recognizing it, and in 3D, it does it really good to other AI. Now, what about seeing if we can do this with different prompts? Can we do it with action unit presence in text? Can we better do it with images? And you can see Llama, for example, can best recognize it directly from the image. And the vision transformer is pretty much on par. That is, if we test it on a standard database, here AffectNet, which has been used in a challenge. So in other words, AI can already emergently recognize also emotion in facial expression out of the box, kind of, if you prompt it with the image and ask what emotion is being shown here. And if you train an AI like we did before, we're a little bit better maybe, but it's quite similar in range. So AI can already synthesize and recognize emotion in large models in the vision domain. And what about the text domain? Similarly here, we're using large models to convert this time a kind of neutral phrase, the weather is clear and sunny, into, for example, surprise, and of course also the other Ekman Big Six ones. We then ask other models like Roberta, fine-tuned, or GPT if they can recognize this. So that's the same kind of protocol as we've been doing for the vision modality. And the weather is clear and sunny turns, for example, with Llama into it comes quite as a shock to discover that the sky has transformed itself into such crystal clarity to express surprise. And if you look at can AI recognize this transformation, other AI, we can find that again, happiness is done very well. But also the bigger models like GPT-4, which is the purple shaded here, can recognize the emotions very well of the different other AIs. In short, similar picture here, happiness works particularly well, confusions are mostly with neutral, and AI can produce emotional text, and it can recognize emotional text. Can it also do so on databases of effective computing emergently? And yes, it can. If you look at a traditionally trained model with a bidirectional long short-term memory network versus a Roberta, we get better results from that even, and it works very well. So AI can synthesize emotion in large models. It can recognize it in image and text. What about speech? Sri has been talking a lot about the audio domain right now, and in the Proceedings paper, we have been looking in particular first into the synthesis, and we have been talking about going large, going deep for synthesis, and summarize the different approaches to voice conversion, speech synthesis in emotional fashion. Somehow, however, it wasn't as straightforward to test this in large models as it was for vision and text, maybe because these were largely driving the large model domain first. Of course, bigger models like Uni Audio can already go from textual descriptions of emotion to synthesis, but as said, it's not as streamlined and obvious yet as in the other two ones. So this would be for conversion. They can also convert a little bit, but all of that isn't as obvious yet. Can they also recognize out-of-the-box emotions? Again, not as easy as with text and image, but the trend seems to be the same. Use transformers that have been pre-trained and fine-tune them on loads of data. Here, for example, we have been introducing X-Hubert, which is a Hubert version trained with 37 emotion databases, so kind of grasping all the emotion data we can get our hands on, and you see the parameters are doubling up from 160 million to 340 roughly, and then you get better results. So what happens next and how can we get even more competitive is the question, and we can see that emotion ability seems to be emergent already from the large models, mostly for the vision domain and the text domain, but coming on for the audio domain. And of course, large models are also trained in other data types. So we will probably soon have it also for physiology and maybe other forms. But what is missing to really make AI take off, I guess, is reinforcement learning at scale. So once we have AI interact with us using emotion in some form, to be communicative in a more natural way, or even to influence or better communicate across humans. Having applications out there in AI learn from the interactions with reinforcement is likely to lift us and elevate us to a whole new level. With that, thanks a lot for the time and interest. And
thank you so much.